are going to be discussing nothing but high temperature processes. High temperature processes. Now, it's interesting to know that you have to share this class. Go to my YouTube channel, Dr. B Science Classes, and in my Facebook, Dr. B Science Classes. You need to subscribe so I can have all these videos played in full, and also these videos pop up whenever they come up on your screen. And then you also have to like. You need to make some comments. If you have questions, drop them. I will attend to those questions. And then on your my Facebook page too, you need to also follow. When you share this, whichever medium you use, you share it. Tell your friends to do what? To share. To click on the follow or subscription button at any of these particular channels. And then you need to like and leave comments as well. Alright, but we're going to be talking about high temperature processes. But do you know that another name for high temperature processes is pyrometallurgy? Pyrometallurgy is another name for high temperature processes. Collectively, these are all high temperature processes, and put together, they are described as pyrometallurgy. But what is metallurgy? Metallurgy has much to do with extraction of metals. Metallurgy has to do with extraction of metals. It has to do with reduction of metals. It has to do with refining of metals. So the three cardinal things that define metallurgy is the production of metals, is the extraction of metals from their metal ore, reduction of metals, and then the refining of metals. All this is what makes up metallurgy. Now, in metallurgy, we have three basic processes, and one of the processes is pyrometallurgy. Another process is hydrometallurgy. Hydrometallurgy. And the other process is electrometallurgy. Electrometallurgy. Now, these three types of or categories of metallurgy explains the different processes by which you can do what? You can either extract metal from their ore, or you can reduce metals or even refine metals. Now, why electrometallurgy has to do with the extraction, refining, or reduction of metals through a process where you use electric current, like electrolysis. Electrolysis is one basic or major process of metal refining, and it falls under electrometallurgy, where electricity is being used. And then hydrometallurgy has much to do with the use of aqueous solutions, not only water. But once you try to extract metals from their ores, or you try to refine metals or reduce metal using aqueous medium, you are using the process of hydrometallurgy. And then the process of pyrometallurgy has much to do with high temperatures, and that is why today you and I will be discussing pyrometallurgy, the use of high temperature processes in the extraction, refining, and reduction of metals from their ore. Alright. Now, we wouldn't want to ask again what is pyrometallurgy, because we have said that pyrometallurgy is simply the extraction, the reduction or refining of metals from their ore using high temperature processes. Simple. That is what pyrometallurgy is all about. Extraction, reduction, refining of metals from their ore using high temperature processes. And in this kind of a process, metal ores that fall around carbonate, that is carbonate ores, okay, something like sulfide ores, something like ores like carbonate ores, sulfide ores. You can also talk about, can look at ores like oxide ores, okay, oxide ores. Now, these three categories of ores are the major ores that are used employing pyrometallurgy or employing high temperature processes. Ores that are carbonate ores like calcium carbonate, ores that are sulfide ores like iron sulfide ores that are oxide ores like titanium oxide. Now, all these oxides, carbonates, sulfide ores, whenever you want to extract their metals like calcium, their metals like zinc sulfide, zinc, There are metals like iron, from iron sulfide. There are metals, okay? When you want to extract these metals from either oxide, sulfide, or carbonate ores, you have to use pyrometallurgy. That is, you have to apply high temperature processes to be able to do that. Now, usually, pyrometallurgy is a process of extracting metals around temperature ranges of about 300 degrees Celsius to 1600 degrees Celsius. Yes. So whenever you want to make use of pyrometallurgy in an industry, chemical industry, okay, you must understand the fact that higher temperatures are required. Temperature ranges between 300 to 1600 degrees Celsius. There is a lot of advantages that is accrued to pyrometallurgy. The advantages that you could see around pyrometallurgy is one is high quality metal. High quality metal. High quality metal. Another advantage you can also see here is minimized environmental impacts and reduced production cost. And many others. But importantly, why industries as a whole make use more of pyrometallurgy instead of hydrometallurgy or electrometallurgy is because of the high quality metal that is always obtained when you use pyrometallurgy, or call it high temperature processes. Again, when you use this method, you reduce much of environmental impact, because most of the environmental waste that is produced are gases, and the gases they lie around carbon dioxide and sulfur dioxide gases. Okay, again, it reduces production cost. Okay, because if you are talking about using electrometallurgy, for example, you will see that you have to be dealing with high supply of electricity. Okay, so it's the same thing with hydrometallurgy. So it reduces production cost, it minimizes environmental impact, and most importantly, it creates opportunity for high quality metal to be produced from its ore. Those are the basic three advantages that you can find with pyrometallurgy. But do you know that pyrometallurgy is used to extract so many metals, especially the alkaline metals and the alkaline earth metals? Now, if you see the smelting of iron using the blast furnace, you will see that the iron ore, hematite, is introduced with other gang materials, which are impurities, okay, through the hub into the blast furnace. And carbon is introduced as coke, which is used as a reducing agent. And then high amount of heat is pushed into the blast furnace from the heart, okay, and this amount of heat is so high that it will do what? It will melt the hematite and allow you to collect the pig iron, cast iron, and also the waste, okay, that come as slag. So you see that one of the very important application of pyrometallurgy or high temperature processes is in the smelting of iron in the blast furnace. Now, another example that you can find so often is in the production or extraction of copper using what? Using a very common process, the reverberatory furnace. You can use the shaft furnace as well for copper, but the reverberatory furnace is always used for the production of copper. And in that particular process, high temperature is also required. And you get about 99.9% pure quality metal, whether it is iron or it is what? Copper. You can also find it in zinc production. Okay, you can find it in zinc production. You can use zinc. You extract zinc using pyrometallurgy. Okay, and then you can see that in the vertical blast furnace. You can see zinc and you can also produce something like aluminium. You can also produce aluminium or extract aluminium through the process of pyrometallurgy using the base process. Okay, the BAY. You can use the Bayer's process. You can use the Bayer's process. You can use the Bayer's process to produce aluminium. Okay, and that process makes use of high temperature. Okay, remember that I've mentioned a few things here, so you have to, so that you can have them with you as possible application of pyrometallurgy or high temperature process. I've mentioned that you can use the blast furnace for iron production, smelting. You can use the Bayer's process for aluminium. You can also use the basic oxygen furnace for production of steel. Steel is an alloy. You can also use the reverberatory furnace to produce for the production of copper, and a whole lot of them, and even zinc. Okay, even zinc. You can use the red torch furnace to do what? To produce zinc. So all these processes, whether it is a blast furnace or Bayer process or basic oxygen furnace or reverberatory furnace, or you are using the rivet process to produce zinc, all of them require high temperatures, and you can get 99.9 pure quality metal through these pyrometallurgical processes. Now that is beautiful to know. Now I want us to know that the basic oxygen process that is used in producing steel begins its foundation from the blast furnace, because it is the pig iron that you produce through the blast furnace that is used in the basic oxygen furnace to produce steel. Steel is an alloy, so you cannot just begin to see I mean a metal ore of steel. There is no metal ore of steel. So for you to produce steel, it means that you have to first use hematite, which is the iron ore, in the production of iron in the blast furnace to get pig iron. Now the pig iron is what you are going to use to do what? To use in the basic oxygen furnace to produce steel. But in all these processes, very high temperatures are required. They are all required in these processes. Now, let us take a look at the basic high temperature processes which you have here. This is calcination. Calcination requires high amount of heat, and that is why it is a process of pyrometallurgy. Smelting is another one. Roasting, melting, dosing, sintering, gas phase reactions, all these reactions and many more constitute high temperature processes. I'm going to look at them one after the other, but very briefly. You can do a further job by reading them through your textbooks. Okay, now when you look at calcination as a high temperature process described by pyrometallurgy, it is simply a process where high amount of heat, high temperature is supplied to a metal ore, okay, such that that temperature will assist the metal ore to give up volatile compound, especially gases like carbon dioxide. And that is calcination. For example, if you decide to extract calcium through pyrometallurgy, you're going to use calcination. And by calcination, it means you have calcium carbonate, which is going to be heated at high temperature to give you what? To give you calcium oxide and carbon dioxide gas. So when you're using calcination, you are heating a particular metal ore at very high temperature, such that there is going to be a release of what? A release of carbon dioxide gas per se at this instance. But it has to be a release of what? Of volatile gases. That is calcination. Now, smelting. I had mentioned smelting already. In the production of iron, if you pass hematite, which is an iron ore, through high amount of heat using the blast furnace, you will end up doing what? You will then end up doing what? Causing the iron ore to do what? To melt and go into a molten state. And when you go into a molten state, you're going to have a pig iron cast iron, and slag. The slag is the impurities, which we describe as gangue. So now, smelting is simply the application of high amount of heat, high temperature to a metal ore in order to do what? In order to transform that metal ore to a molten state, where you can now be able to do what? To reduce and then refine into a pure metal. That is smelting. A typical example of smelting, like I said, is in the blast furnace, smelting of iron into pig iron, cast iron, and slag. Okay, now this is roasting. Roasting is simply the application of high amount of heat or higher temperatures to a metal ore in the presence of air. That is simply what roasting is. You supply high temperatures to a metal ore in the presence of air. Usually, roasting is a process that has much to do with reduction of a metal from its ore. And then you have melting. Melting is different from smelting. While smelting has much to do with a supply of higher temperatures and then converting iron ore into its molten state. Melting is simply an act of supplying high amount of temperature or high amount of heat to a metal ore such that the heat is supplied above what? The melting point or around the melting point of what? The parent material. So in melting, you are supplying heat at high temperature such that the metal ore will receive heat at the temperature either equals to or greater than its melting point. And at that point, it is going to melt. The parent metal is going to do what? It's going to melt off. Now that is melting. For want of time, okay, we will have been writing some chemical equations alongside so you understand what we are talking about. But now you have the idea, you can read further. Now, dosing is another method. Dosing is another pyrometallurgy or high temperature process. By dosing, we simply mean supply of higher amount of heat or higher temperatures to a metal ore such that the metal ore is going to do what? Melt. And when it melts, you can be able to collect what? The impurities floating on top of the liquid metal. So it means that in dosing, you need so much high temperatures because the metal must melt, the iron ore must melt completely into what? Into a liquid form such that what? The impurities or the gangue materials will float on top of the liquid metal for you to do what? To collect them. That is dosing. Now, sintering is used in powder metallurgy. Powder metallurgy. So it means that in sintering, you are expected to ground that particular metal ore into powder. And then you supply high amount of heat such that the powdered material will be fused. And as it is fused, we call it sinter. Okay, as it is fused or form a sinter, it can now be transferred into where reduction can take place. That is sintering. Fusing of what? Fusing of what? Of powdered metal or powdered metal ore by high supply of what? Heat. And then you have gas phase reactions. Gas phase reactions are simple. Gas phase reactions is where you choose to introduce, okay, you choose to utilize some sort of volatile gases in a reaction. Reactions that involve what? Involve mostly gases or volatile materials. So when you want to extract a particular metal from it, or you have to understand whether this particular ore or the parent material you want to get can be able to go into a gaseous state and then recollect it. In that way, you'll be able to make use of the gas phase reactions. Now, these reactions that I just explained are reactions that you can, or rather, these processes I just explained are processes you can be able to point to pyrometallurgy. And these are processes that you call high temperature processes. Now, do you know that if you want to make use of high temperature processes, okay, there are some things you must take note of. Okay, because you cannot just begin to carry out a certain extraction or certain refining or reduction of metals using pyrometallurgy without understanding some basic considerations that are necessary. Now, looking at those considerations that are necessary, before you use pyrometallurgy or before you make use of high temperature processes, there are key or major considerations you must take note of. And one of those considerations is that you must understand the fact that this involves energy. There is energy consumption. There's energy consumption. You must understand that. You must also understand that there is environmental impact. There is environmental impact. You must also understand the fact that there is material selection. Material selection. Okay. You also must understand that another consideration is that there is heat transfer. Heat transfer. And finally, that there is thermodynamics involved. Now, before you venture or before you appreciate or begin to appreciate the use of high temperature processes, because we say that it gives rise to high quality metal, it minimizes environmental impacts, and it also reduces cost of production. Very interesting. But before you go into it, you must understand that there are key considerations. There are major things you must understand before you start attempting to use it. Now, one is energy consumption. You must know that this process makes use of high amount of energy. 300 to 1600, that 1600 degrees Celsius is not small. So you must make sure there is an availability of an energy source high enough to supply a continuous amount of energy to the production process. Else, you won't be getting it all wrong. Now, the next thing is that environmental impact. Like I said, even though we do not have much of environmental impacts from pyrometallurgy compared to hydrometallurgy and electrometallurgy, there is still some gases like sulfur dioxide gases, carbon dioxide gases that are expected. So you must find a way of managing sulfur dioxide gases and carbon dioxide gases that are the major gases or major threats that is being obtained from high temperature processes. Now, another thing you must know is the material selection. Remember that you are talking about high temperatures here. So if you are using blast furnace, for example, blast furnace, the rotary furnace, the Bayer's process, or you are using whichever furnace you are using, you must carefully select the type of material in terms of the type of metal. So if the blast furnace is made up of steel, what type of steel? Is it carbon steel? Is it stainless steel? Okay. Is it carbon? Is it mild steel? So you must understand what material is your extraction chamber made up of. And then what material are you actually trying to extract? Is there a possible interaction between them? So material selection is very important in order to get what high quality metal. Now, heat transfer is another thing. Remember that there are three basic types of heat transfer. Heat transfer by conduction, heat transfer by convection, and heat transfer by radiation. There are three basic heat transfer processes: conduction, convection, and radiation. We are not talking about that today. But just take note of that as far as there are three different types of heat transfer, if you are using the pyrometallurgy or high temperature processes that are here, you must understand whether the material that you are trying to extract, that is your iron ore away from the gangue, which is the impurity, is going to be affected by either conduction, convection, or radiation. If you don't understand this, then you go venture into high temperature processes to do your extraction, you will have a big problem in terms of those three cardinal advantages we've mentioned. And finally, thermodynamics. I hope you know that thermodynamics has to do much with enthalpy, entropy, and most importantly, the Gibbs free energy. So the free energy part of thermodynamics plays a serious role in high temperature processes. Through the Gibbs free energy, you will understand whether the reaction process, the extraction or refining or reduction process you want to carry out using pyrometallurgy is feasible or not feasible, and whether the reaction is stable or not stable, or whether the system of reaction is stable or not stable. Now, if you understand these basic considerations before choosing high temperature processes in your extraction, refining, and reduction of your metals, then you will be able to get the best and high quality metal out of pyrometallurgy, out of high temperature processes. We are going to end our class here today, but always know that this is quite an interesting class, and many other lectures that we have already and the one we're going to be having forward from here. Do not forget to share, don't forget to like, don't forget to comment. If you have questions, ask. We are going to answer those questions for you. Dr. B Science Classes is my Facebook and also my YouTube channel name. Now I'm going to give you an assignment. Now this is the assignment. The assignment is simple. The assignment is explain ion production. Explain ion production using okay, let's explain explain ion production using, I'm trying to get the right question for you. Explain ion production using blast furnace. Using blast furnace. Okay, and this has to do with smelting. Okay, so this is your assignment. Do it and see if there's anything you learn more from smelting as one of the high temperature processes. Explain ion production